All right, welcome back. So previously we have talked about the problem where we say that in the traditional neural network, it becomes difficult to trace back, okay, especially when you're dealing with sequential data, okay, it becomes very difficult if you want to trace back and then have the influence of past data, okay, that becomes quite a challenge over there, right? Okay, and then we also said that the solution that we can use is what is referred to as recurrence, right, or state. All right, we have what is called recurrent neural network, right, which has memory, which can keep past information and then use that past information to influence the current output or the current outcome. All right, so going forward, that's the only thing that we're going to depend on. Okay, recurrent neural network. All right, so in traditional machine learning, we only have something like this where we have a data point and then you feed the data point to some sort of algorithm, then it will give you an output. Okay, the best that it can do is to maybe take the past maybe 2 or 3, just give it some kind of a fixed window, then take the past 2 or 3 data points over there, okay, and then use the current data points together with that and then feed it to a model and then maybe give you an output. Okay, now we want to do more than that. Okay, we want to do more than that. So we say that we have what is called recurrent neural network, which has memory. Okay, and all it does is to keep memory or keep the state of the previous one, right, and add it to the current state to give us an output. So instead of just having an output and then straight away feeding it to some sort of a function and getting the output, we also take into consideration the previous state, okay, the previous hidden state, and then apply some sort of a weight over there, right, and then the current hidden state, and finally we apply the function on it and then get the output. Okay, we're going to see how this thing works. Over here, what we're trying to say. So now let's take this recurrent neural network and try to understand it. Okay, let's try to understand this recurrent neural network. Okay, so we say that the recurrent neural network is a type of artificial neural network. Okay, it's not something superficial that we are bringing in. It's a type of artificial neural network. What we have already learned so far is what we are basing on to improve, right? But in this case, we are focusing mainly on sequential data, okay, or time series data. That is data that depends on previous data, or maybe future data, okay. But the current data, whatever the case may be, the current data actually depends on some sort of data, okay, whether previous or future. All right, so that is what recurrent neural network does. Okay, it's recurrent because it keeps on repeating, right? It's repetitive. Okay, repetitive. Okay, recurring. It recurs. It repeats. Okay. So the ordinary feed-forward neural network, which we have already seen, like fully connected neural network or CNN, right? What they do is they are meant for data points, right, which are independent of each other. Data points which are independent of each other. So you don't care about what happened 10 years ago. What you care about is the data points that you have, and then you feed it into your neural network and you get your output. Okay. However, if we have data, right, in a sequence such that one data point depends upon the previous data point, then we will need to modify the neural network, okay, to incorporate that kind of dependencies that are between these points. Okay, we need to modify the traditional neural network to incorporate that dependency that is between the data points. Okay. Now these RNNs, as we talked about, they have what is called memory. Okay, they have what is called memory, and this memory helps them to store the states. Okay, or information of previous inputs. Okay, to generate the next output of sequence. Okay, so that's what the recurrent neural network is going to do for us. It has memory. Using this memory, it keeps the state, right? The state or information, you can call it info. Okay, state or info of past data, and then based on that past data to help us work on the current data. All right. So basically, that is what we do. So whatever output that you're going to have, right, is influenced by the past data. Okay, it's influenced by the past data, not only the current data, but it's also influenced by past data. Okay, because the recurrent neural network is having the capability to keep the state or the information of the past data. It has a memory to keep that. All right. Okay, so this is how the scenario looks like. Okay, it has what we call as loops. Okay, it has loops in them which allow information to persist. Okay, so if you take this architecture that we have, which is a very simple one, right? It's just a chunk of the neural network. Okay, we call it A. Right, so we can have A, B, C, right, several of them. Now, this recurrent neural network, what it's trying to do is that it's looking at a data point ST, okay, looking at a data point ST, and then it's going to output an output here, which we refer to as HT, okay, and the loop actually allows information to be passed from one step of the network to the next step. Okay, so you can see that we have some symbol over here which saying that whatever that we are doing, we are going to do it many times. Okay, we are keeping on looping instead of if you pick traditional neural network, you feed it forward. Okay, you feed it forward and then maybe you do back propagation like that. But in this case, we loop through, right? We loop through to make sure that we take care of past information as well. Okay, so this one here can be expanded. I mean, it's a loop, so which means that when it does one, it does it again, then it does it again, then it does it again, something like that. So we can actually expand it this way. Okay, we can actually expand it this way. So one of it, let's say it started with this one, right? Then it does it. It has the data point. It passed through to get an output, right? And then it does it again. Okay, it does it again. So here we have an S2. We feed in another data point, right? Then it gets an output. Then it does it again, S2, right? We have an output. Then it does it again. 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 Something like that. Okay. So to keep on doing that kind of loop for us and getting an output for us. Okay. So output 0, output 1, output 2, output 3, like that. Okay. So in order for you to get an output 1, it means that you need the information from output 0, okay, to be fed to this. In order to get output 2, you need the output from this state, okay, to feed to this part. Okay. In order to get the output of the next one, you need the output from here, right, to feed to this one. Okay, so that's basically what it does. So you can think of it as multiple copies of the same network. Okay, which each passing a message to a successor, right? Okay, so that's basically what recurrent neural network does, right? And there's a lot of applications of this recurrent neural network. Okay, you can think of it in speech recognition, right? We use recurrent neural network. In language modeling, we use recurrent neural network. In translation, right, for translating from one language to another, we use recurrent neural network. In image captioning, okay, for instance, you can be watching a video, right, and under the video there will be some caption over there. Okay, that is as a result of recurrent neural networks. Okay, that's as a result of recurrent neural network.